Thank you for joining us, and I'm going to break things step by step for you to understand what I'm going to do here. So let's jump right in. Don't forget, we are looking at fall 2023, and then spring 2024 will follow up right after this video. So now let's look at what the question is asking us. Now, the question is asking us to find the average rate of change, right? From t is equal to 1 to t is equal to 3. So we can use any of the formulas that we have here based on the function given to us. So they've given us f of t, so it's good for us to use this right here. So now what I'm going to do here is I'm going to assign t is equal to 1 as my t1 and t is equal to 3 as my t2. So it means that the average rate of change here is going to be f of 3 minus f of 1 divided by 3 minus 1. So very simple. And what we need here is, for you to avoid mistake, it's good for you to just pick this one and look for f of 3 and then look for f of 1. Don't try and write everything like equal to and try to do everything here. Sometimes when you do that, you get some mistakes or you make some mistakes. So the best thing to do here is just pick f of 3, and then now the function given to us is f of t is equal to 10 plus t squared. So what I'm going to get here is I'm going to have 10 plus 3 squared, and this is going to give me 10 plus 9, and this is going to give us 19. So that's basically what I'm going to get here. Then I'll look for f of 1, then I'm going to have 10 plus 1 squared, and this is 10 plus 1, which is equal to 11. So what did I do? I just did it step by step. I didn't try to put everything on the top here to simplify. Simplify this, and then just use the results. So this is going to give us 19 minus 11 divided by 3 minus 1. And this is going to give us 8 divided by 2. And this is going to give us 4. Very simple. Very, very simple. So I do this to avoid what? Mistakes. I do this to avoid mistakes. Let's look at question B. Okay, so B, we are looking at now the average rate of change. Now our T1 is still 1, but T2 has changed from 2 to 1 plus H. So we are going to have f of 1 plus H minus f of 1 divided by 1 plus H minus 1. So don't forget, what is here is what you are going to use here, and what is here is what's going to be here. So same idea, look for f of 1 plus H. Now from here, because we are using the same function, f of 1 is already evaluated here. You just did, and we had 11. So we can just ignore that one and just focus on this. Now let's look at how you can expand this. Can expand this. So we are going to have something like this: 10 plus 1 plus h squared, right? So because the function given to us is f of t is equal to 10 plus t squared. Now our t is 1 plus h, so I need to have 1 plus h in parentheses or squared. Now this is going to give us 10 plus 1 plus h all squared is the same as 1 plus h, 1 plus h. So this is what I'm going to get. So this is going to give us 1 plus, then I'm going to expand this and have 1 plus 2h plus h squared. So that's what I'm going to do here. So I did 1 times 1. 1 times h is h, and then h times 1 is also h. When you add it, you get 2. And then 8 times h is going to give us this. So it means that this is going to give us 1 plus 2h plus h squared. So now we know that f of 1 is equal to 11 from here. So now what we just need to do is we just need to just use the results that we have gotten here. So we are going to have 1 plus 2h plus h squared minus 11 divided by, this is going to give us h. So we are going to have something like divided by h. And then the magic happens here. This will cancel this, and we are going to have 2h plus h squared divided by h, and we can write this one as h out, 2 plus h divided by h, and then h cancel h, and we are going to have 2 plus h. So it's very simple for us to just do the whole of this and get the results and just use the final results here to evaluate instead of doing something like this. So you see, some of the students, some of you just do something like this: f of 1 plus h minus f of 1 divided by 1 plus h minus 1. Then you try to write everything here again by doing direct substitution for this one in, and you do something like 10 plus 1 plus h squared minus, then you are going to do something like, if we are doing for f of 1, you are going to do something like 10 plus 1 squared divided by 1 plus h minus 1. And automatically, when you do something like this, you have gotten something wrong, because you see, this minus here is not going to affect this, because this one should be in parentheses. That's why it's good for you to just evaluate this and do this and use the results, so that you know that, okay, now it's just the minus affecting this. So as soon as you do something like this, you have gotten it wrong, because this one should be in parentheses to make sure that this one too is minus here. So pay attention to this one. Is very important. Sometimes when I'm marking, or when we are marking, we see some small mistakes. You know what you are doing, but you are not taking your time to do it step by step, and you get messed up somewhere. So now let's look at question C. So C, we want to find the instantaneous rate of change, right? Or the instantaneous velocity at t is equal to 1. So what we are basically looking at is, okay, now we don't want the h again. We want to see when h is approaching 0, what happens to the function. So it's basically finding limit as h is approaching 0 of the results that we had here. So we had 2 plus h. So we are just going to use that and we are done. So we are going to have 2 plus h, and then I'm going to set h to equal to 0, and then just have 2 plus 0, and this is going to give me 2. So when you get a question like this, you should be able to, take your time and then do it and get everything right from there. Let's look at question 2. Question 2, we want to find limit as x is approaching 2 from the positive side, negative side. Then now we can conclude for this, right? Because for us to conclude on this, we need to have this and this to be the same, or not to be the same. Then we can conclude. Now, this is the same as limit x is approaching 2 from the positive side. Now, from the positive side means that the value is greater than 2 when you see the positive. So this positive means that the value of x is greater than 2. So which one is greater than 2 is this one. You see that the value of x is greater than 2 here, so we are going to use this function here. So this is going to give us 5 minus x squared. Then I'm going to set x to be equal to 2. Now don't forget, the plus here is just showing us that we are coming from the positive side. So we are using x is equal to 2. And this is going to give us 5 minus 2 squared. And this is 5 minus 4, and this is equal to 1. Very simple. Let's do this one too. We are going to have limit x is approaching 2 from the negative side. Now, negative side means that the value for x is less than 2. So anything less than 2 is here. So we are going to use this. So we are going to have 3x plus 1. Then we are going to set x to be equal to 2 here. And we are going to have 3 times 2 plus 1, 6 plus 1. And this is going to give us 7. So what will be the conclusion for this? Since this is not the same as this, we are going to say that this does not exist. So this does not exist because A is not the same as B. So that's what we are going to get for question 2. Question 2. Now use the squeeze theorem. So here we want you to use the squeeze theorem. So you should be using squeeze theorem to solve this. So let's try and use the squeeze theorem here and see. Now for us to use squeeze theorem, we need to set up an equation. We know that sine is always between 1 and -1, right? So no matter the angle, so the angle can change, still we are going to lie between -1 and 1. So it means that now here I need to look at the function first, which is sine, and then I have -1 less than or equal to sine of x minus 1 less than or equal to 1. Right. Now, what I want to do is I want to build this function here. So since I have sine of x minus 1, I can see that this function is divided by x squared. So for me to get something like this to look like this, then I need to also divide this one by x squared. But I cannot do something to this without doing to this and this. So I'm going to have this one to be minus 1 divided by x squared, and then sine x minus 1 divided by x squared divided by less than or equal to 1 divided by x squared. So now we see that we have gotten something like that, which is the same as this. Now, what we need to do is, now this function here is having limit as x is approaching infinity. So we need to have limit on this. And as I said, we should do to this and the same thing to this, anything that we are doing to this. So now this is going to give us limit x is approaching positive infinity minus x squared less than or equal to limit x is approaching positive infinity x minus 1 divided by x squared less than or equal to limit x is approaching positive infinity 1 divided by x squared. So what do we see here? We see that this function here is right here. So we've built the function, right, with the limit, which is in between this. So now we are going to use the Squeeze theorem to evaluate this. Now we are going to find the limit on the left and then on the right to find out whether they are the same or not. So let's see what happens here. Now limit here, when I decide to plug in infinity, infinity squared is still infinity, and 1 divided by a big number is going to give us 0. So you are going to have 0 less than or equal to limit x is approaching infinity sine x minus 1 divided by sine squared divided by x squared times, less than or equal to, then this one too is going to give us 0 as well. So this is also 0. So this is 0, this is 0. So what will be the conclusion? This limit here should be equal to 0. So that's basically what we are going to get from here. This limit should be equal to 0. So it's kind of very straightforward for you to just take your time and then do them step by step. Now let's look at this function here. So anytime you are doing limit, this is one idea that you need to have. No matter the function, whether a rational function, polynomial function, radical function, try and do direct substitution first. That is the best thing that you can do. But this is a rational function, so we are concerned about the denominators, right? So let me put x is equal to minus 2 here and have 4. So this is going to be 0. So since it's going to be 0, then it means that we don't have any option. We need to simplify. Yeah. So now this is equal to limit x is approaching minus 2. Then we can simplify the top and simplify the down. So let me do that one here quick, right? So we need to pick two values now that are factors of 8. So factors of 8, we have 1 and 8. We have 2 and 4. And yes, I think that's all, right? Good. So we see that this pair here is going to give us, so now this is 2 and 4. So I'm going to use 2 and 4 to do this. And when I do that, I'm going to have x plus 2 and then x minus 4. Why did I see that? Because now for me to use the 2 and 4, I need to get negative 2. So I'm going to use minus 4 and 2. So if I'm using minus 4 and 2, then this is what I'm going to get at the end of the day. So now divided by, this is difference of 2 squares. So I'm going to have x plus 2, x minus 2. So now I'll be able to cancel this and this out. And I'm going to have limit x is approaching minus 2, x this divided by x minus 2. So now that we are done with simplification, we can just do another direct substitution. So set x is equal to minus 2 minus 4 divided by minus 2 minus 2. This is going to give us minus 6 divided by minus 4, and this is going to give us 3 divided by 2. Very simple. Now let's look at b. B here, you need to pay attention to this one here. X is approaching infinity. So what you are going to do here is different from when x is approaching a finite value, right? So when x is approaching infinity, then it means that the polynomial function with the highest degree is going to dominate. So I look at the function and look at the one with the highest degree. So I see that I can write this one as limit x is approaching negative infinity. I can write this one x squared divided by, pick the one with the highest degree here, which is minus 4x squared. So I'm going to have this one to be minus 4x squared. Then now x squared will cancel x squared. So this is the same as limit x is approaching minus infinity. And I'm going to have 1 divided by minus 4. And this is minus 1 divided by 4. Because this does not depend on x. So it's just giving us the constant here. Another way of doing this is you can also say that, okay, fine. The degree of the numerator is the same as the degree of the denominator, right? So now I can say that I'm going to pick the ratio of the degrees. I'm going to pick the ratio of the coefficient. So the coefficient of this is 1. The highest degree here is 1. The coefficient of this one too is minus 4. So it means that this is going to give us minus 1 over 4, because I just picked the ratio of the degree of this divided by the ratio of this. So that's what I'm going to get from here. So any of them works. You can just use this or use this. You can also divide. That one is too long, so let's stick to this too. Now, as I said, always direct substitution first. So let's do direct substitution here. Set s is equal to pi. So 3 cos of pi plus 5. Don't forget, we are not using calculators, so you should be able to be good with sine graph so that we will know that cos pi is negative 1, right? So this is going to give us cos of minus 1 plus 5 minus 3 plus 5, and this is going to give us a big 2 from here. Okay, let's look at question 5. Since you are taking calculus 1, you should be able to know how to draw graphs. It's very important because you are going to draw them every day. So now let's look at how I sketch graphs, right? So when I sketching graph, I try to do the easiest one. So this is the easiest one. So I just plug this one. F of minus 2 is 0. So f of minus 2 is 0. So I can have it here, right? So let's assume that this is minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. So this is what I'm going to get from here. So minus 2, and this one is here. So I just take this one, meaning that I've done that. Now, don't forget, anytime you are dealing with something like this, let me show you something here. Anytime x is approaching infinity, think of something like horizontal asymptote, right? And then anytime you see something like x is approaching finite value, you just think something like asymptote, even though that is not true, right? But just think about those things, right? So what I'm going to do here is, for me to sketch the rest of the graph, I'm going with the one that x is approaching finite value before I go to the one x is not approaching the finite value. So now I need to pick them. I have x is approaching minus 2, and I have x is approaching 2. So let me start with the 2. So on the 2, I have one from the left and then one from the right. So from the right, I have something like minus 1. So I can have something here. And then I'll have some small tail here showing me that I'm going to the right. And then on the left, I have 3. So I can have something like 3 here, maybe something like this here. I have some small tail here telling me that I'm going to the left. So done with this, done with that. Let's look at this guy here. This guy here is x is equal to s is approaching minus 2, and we are getting 1. Now this here tells us that limit as s is approaching minus 2 from the left is also 1, and limit x is approaching minus 2 from the positive is also 1. So this one was true. That's the reason why this is equal to 1. So if you see a limit without left or right, automatically know that the left and then the right are coming to the same point at 1. So at 1 here, I'm going to have a tail from the left and a tail to the right. So that's what you need to remember here. So now I'm done with this one too. Now x is approaching infinity. Now x is approaching infinity is equal to 1 is a horizontal asymptote, right? So that's basically what we are doing here. So I'm going to do that and have something like a horizontal asymptote somewhere here. Just change the color here. So I'm going to have something like this. Good. So I'm done with this one too. And then the last one here says that when x is approaching negative infinity, I should be going to positive infinity. So it means that the graph that I have here, I'll be moving up like this, because when I'm approaching it from the negative infinity, I should be going to positive infinity. So that one tells me where I'm moving towards. So this one can move up like this, right? Because as soon as I'm going on the negative side, I need to move to positive infinity. So this one too is done. So the rest is to join the graphs, right? Now you can see that I have one here, one tail here moving to the right and another tail here moving to the left. So I can combine this graph together and have something like this. Good. And then I have one here moving to the right, but moving to the right, I need to go under this line here. So I'm going to have something like this moving towards this line here. So that's basically how the graph is going to look like. This one, I can decide to shade one of them because the question did not ask us to, we don't have f of 2, right? But it can be any of them, right? It can be somewhere here, it can be anywhere, but you can leave it like that and then you are done, because that was all the information given to us. So this is the graph for the function. Now let's look at question 6. I think this is the last question. Yes. So since they can give us information for us to draw the graph, then we can also give you the graph for you to find out the information, right? So that's basically what we've done here. So we have given you the graph and we want you to do this. And when they give you the graph, that one should be easier than drawing the graph itself. So let's try and figure it out. Starting from A, x is approaching 1. So let's look for 1. So 1 is here, and this is what I do. I will just draw a line on the 1. As soon as I draw a line on the 1, here becomes the right and here becomes the left. So I look close to 1, the graph on the right and the graph on the left. So this is the graph on the left, this is the graph on the right. And then I trace it along this line. So on the right, this is the graph. So I need to go along this to get to the blue. So when I get to the blue here, I branch. This is a -2. So this is going to give us -2. Then let's go again. On the left, this is the graph on the left. So move till you get to the blue line, and this is going to give us 2. So this is also 2. So what will be the conclusion? Since this one, the left and the right are not the same, we are going to say that this does not exist, right? D and E, it does not exist from here. Let's look at f of -2. Let's look at x is approaching -2. So x is approaching -2. I'll have my line on -2 like this here. And as I said, anytime you don't see positive or negative, it means that for us to conclude on this we need to look at the negative side and then positive side. So on -2, this is the positive side and this is the negative side. And we see that they are all meeting at one point. This is coming here, this is also coming here. So we get to the y-axis and we have it to be 1. So this is equal to 1 because the left is approaching it to 1 and then the right is also 1, right? So they all meet at one point. So we are getting it to be 1. Now let's look at 2 from the positive side. So 2, okay, I have a line on the 2 already. So the graph on the positive side this. So we need to approach this line here. And when I'm approaching this line here, you see that I'm going toward negative infinity on the y-axis. So this is basically equal to negative infinity. And then the question is asking for f of 2. So for us to get f of 2, we need to also look at approaching 2 from the negative side. Okay, we have it here. So we can look at this one before we can conclude for this. So on the negative side is here. So you can see that this is the line and we need to approach it along this line. So that one is going to positive infinity. So we are going to have this one to be positive infinity. So automatically this does not exist. And then now we need f of minus 2 and an f of 2. So what is f of minus 2? F of minus 2 is the one which is closed. So minus 2 and then the one which is closed is here. So this is going to give us 3. And then f of 2 is the one which is closed here and also going to give us 1. So this is going to give us 1. So this type of questions are very easy to, get the solutions right. And then I think that's all for this one. And in the next video, we are going to also take another section, which is spring 2024. And then the next one we are going to take for 2024. All right, see you in the next one.